Good morning and Assalamualaikum. My name is Nurlan Sunas and I am going to record a lesson about grade 6 science, and the topic is material changes. The learning outcomes for today's topic are that you are going to observe some daily life reactions or changes and infer the type of change, that is, differentiate between physical and chemical change. Now, as the topic is material changes, material you all are very well aware of. Changes, what is a change? Can anyone tell me what's change?
Continuous process.
It is a continuous process, okay. What else?
Different changes in different shapes and size or position.
Okay. It is a continuous process. The size or shape
Or something switching or altering.
switching
Or replacing something
or
with something new.
Okay, replacing.
When it's changing its form,
Very good. Replacing something with something new. Change of form, you said?
and something is changing its form.
Change of form or structure. Okay. Now look at all these changes that people said. They are all different changes. In some of the changes, the size and shape is getting changed. In some of the change, the form is getting changed. Something is being replaced with something. It is switching, altering. Now focus on all these changes and tell me, how can you say that it is a change? Changes, in short, changes are difference. Change is a difference. ठीक है? When something is being changed in shape and size, it means it's getting different from its original form. Its looks are getting changed.
Yes.
ठीक है? Here, if you are replacing it with something new, a completely different thing is going to be there instead of the previous one. So this kind of differentiation, when you people focus on this, you will get to know that whether the change is either physical change or whether it is chemical change. Keep this thing in mind. Whenever the change is physical, means that it is reversible. For example, if you can see, I have this ice in my hand, and what is happening to this ice? As it's very hot today, so what is happening?
It is melting.
It is melting. So what can you say? Melting is what kind of a process?
I think physical.
Melting of ice.
I think physical because it is reversible.
But okay, so it means that it is a physical change. As you said that it is a reversible change. Physical changes are mostly irreversible. And the most important thing of that is the main substance. Here in case of ice actually it is water, which is H2O. Before melting it was water, and after melting it is also water. Is there any change in the composition of this state, this substance?
No.
It is still the same.
Remains same.
It was water before and it was water after. Only what has changed?
Form is changing.
The form is changed. ठीक है? The state of the matter is changed. In this form, in ice form, it is solid, and in simple liquid, the fluid form, it will be liquid water. It will be in the form of fluid. These are what? These are physical changes. But if you focus here on this point that you will share, replacing something with replacing something new. How can you replace something with something new? Any example from your daily life? Think over it. Yes.
Cooking.
Cooking. Okay. How are you changing in cooking?
Raw meat or
Okay.
chicken, we change it into cook by putting vegetables in it, onion, tomato.
Very good. The chopped vegetables and the onion or the tomato or whatever you are mixing together and heating it up. After some time, it will give you something new. Now here, everything is jumbled up. It will give you a new. The texture is changed. ठीक है, the color is changed. It will give you a flavor. Very good. An aroma of the spices will be there. So this is completely new thing. Can you eat a raw meat?
No.
Can you?
Impossible.
Our vegans do, but we don't. ठीक है? And this is the thing that something new is here, the cooked food that you said. But if I'm making salad, for example, I'm chopping the cucumbers, I'm chopping the onion, the tomatoes, I'm putting it up in a plate. Now this making of salad is, it is a physical change. Why? Because the cucumbers are still the cucumbers. Although the shape of the cucumber is changed. Okay? It was first in a cylindrical form, I chop it, I cut it, now it is in the form of cubes, that's it. But cucumber is still a cucumber. Onion is still an onion. These are what? These are the examples from your daily life. So this kind of change where chemical reaction has taken place. While you are cooking, you are heating it. If you put everything together in the cooker and you put it on the stove, you did not turn on the stove. What will happen? Will it cook? No. So for doing this thing, there is a proper procedure of cooking, a proper method. That proper method here, you can see it is a chemical reaction which is taking place. And as a result, you get cooked food. Clear about this thing? Now I want you people to do some activity. I am giving you some stuff. Please arrange yourselves in 3 groups. And then I will give you some things. Okay, now that you people are arranged in groups, I am going to give you these sheets. These are your research sheets, fine. Whatever activity you are going to do, the instructions are over here and you can see that observations and conclusions are here. You are going to observe whatever is happening, you are going to record it in your sheet and then you are going to conclude at the end on the basis of your observation that whether the change or the activity that you did, is it a physical change or a chemical change. Okay? Okay, to group 1, I am giving you this ice cubes. Observe these ice cubes for 1 or 2 minutes and write your observations on the sheet.
Okay.
Okay, to group 2, I am going to give you a vinegar and this is baking soda. Okay, baking soda, vinegar is also known as acetic acid and baking soda is also known as sodium bicarbonate. You're going to, as the instructions are also mentioned here, you're going to mix both of them together and you have to observe what is happening, write your observations and on the basis of your observations you're going to conclude the activity. What change is it physical or is it chemical change? Okay.
The bubbles are coming out.
Very good. Okay, group 3, I am giving you a glass of water and here you can see I have already kept some salt for you. You are going to add both of these things together and as the same instructions for you people, record your observations and then conclude the change. Okay. Okay, I hope all of you are done with your conclusions and observations. Are you?
Yes.
Okay, group 1. Can you please tell me what happened in your activity?
When I observed the ice was melting into water, and you all know that it is a process. Then when again we put this water in freezer, or it will become ice.
Ice again.
So it is a physical reaction, and it is reversible.
It is a physical change and it is a reversible change. Very good. Clap for Amna. Very nice. G. Group 2.
When I have combined both the things, the sodium carbonate and the vinegar, both of them did the chemical reaction and it changed its form. So and bubbles got formed.
Bubbles were formed. Very good. So this I was about to ask you, how do you know that it is a chemical reaction that is taking place? So the bubbles, they are what? They are the evidence that some kind of a chemical reaction is taking place. What do the bubble tell you? What do the bubble tell you?
There is some gas is produced.
Very good. It tells that some kind of gas is being emitted as a result when you added the vinegar with the baking soda or the sodium bicarbonate. Excellent. Clap for students. G group 3.
When I have combined water and salt, water dissolved in the water, salt dissolved in the water, and the process basically is physical process, physical
Very
change.
good. Very
And
good.
we can easily separate both the water and the salt through the evaporation process.
Excellent. Clap for Sarah. Okay, now I hope all of you know that what is a physical and what is a chemical change. And by doing this activity, we did not use any kind of fancy chemicals or substances. We use all these daily life things that you use. The table salt was there, the vinegar was there, the baking soda was there. These things you use in your daily life. It means that these changes, whether they are physical changes or they are the chemical changes, they are happening throughout in your daily life, but we don't notice that these changes are taking place. Specifically the chemical changes, we don't even bother that a chemical reaction is taking place in front of us. Okay? But it is taking place. Now this is your homework for today, that you people are going to observe and search for 3 physical changes and 3 chemical changes around you other than the examples that we discussed today in the class. Okay? And tomorrow inshallah I'll take your feedback. Thank you so much
Thank you,
everyone.
ma'am. Thank you.
This video is going to be about physical and chemical changes. I'm going to do some things here on my kitchen table, and you need to be a science detective and identify the physical and chemical changes that you see here. And then we'll finish off with our top 3 exam-oriented questions on this topic. Before we start, let's do a quick recap on physical and chemical changes. In a physical change, no new substance is formed and it's reversible. But in a chemical change, a new substance is formed and it's irreversible. So the 2 important questions to ask yourself when deciding the type of change are: is a new substance formed? Is it irreversible? If the answer to both of these questions is yes, then it's a chemical change. Otherwise, it's a physical change. So watch carefully the things I'm doing here, and you try to classify them as a physical change or a chemical change. So are you ready? Let's start. I'll start by lighting this candle here. Now I'm going to make some lemonade. I'll show you my recipe. Hopefully it turns out good. So first, cut the lemon. I need powdered sugar. So I'm going to crush this raw sugar in the grinder here. Then mix the powdered sugar and water. Stir it so that the sugar dissolves nicely in the water. Now squeeze some lemon and add a pinch of salt. Let's drop in some ice cubes. I'll wait for the ice cubes to melt so that the lemonade becomes cool. Now let me enjoy the lemonade. It's perfect and refreshing. The candle is still burning. Can you see the wax that has melted here? Are you ready with your answers? In all the changes you saw, these are the chemical changes. In these changes, some new substances are formed. And here are the physical changes. In these changes, no new substances are formed. A burning candle is an interesting example where both physical and chemical changes are taking place. The physical change is the melting of the wax, and the chemical change is the burning of the candle. Now that we've looked at the examples of physical and chemical changes, let's look more closely at the differences between the two. For physical change, we'll use the simple example of melting of ice. And for chemical change, we'll use the example of burning of a candle. The first difference is that in physical change, no new substances are formed. So for example, when ice melts, you get water. It may look different, but chemically it's the same. It's H2O. If we try to represent the melting with a reaction, it would look like this. As you can see, it's water, H2O on both sides. Only the state is changing from solid to liquid. In chemical changes, new substances are formed. So in the burning of the candle, what are the new substances that are produced? The candle is a hydrocarbon, and on burning, it gives out carbon dioxide and water vapor. Of course, we can't see that because they are colorless gases. Here is the simple unbalanced equation for burning of a candle. As you can see in the equation, the hydrocarbon is combining with oxygen and producing carbon dioxide and water vapor. The second difference is that physical changes are reversible. They are temporary. For example, the melting of ice is temporary. We can easily reverse it by refreezing the water back. Chemical changes, on the other hand, are irreversible. They are permanent. For example, the burning of candle is a permanent change because once the candle is burnt, there's no way we can get it back. Let's add these two important differences between physical and chemical changes on our concept board. The third difference is regarding mass. In a physical change, the mass of the substance remains the same. But in a chemical change, the mass of the substance generally changes. Let's go ahead and verify this with the help of a simple experiment. In this experiment, let's measure the mass of the ice cubes before and after melting. First, let's measure the mass of the ice cubes. As you can see, it's 33 grams. Now I'm going to let the ice melt. After all the ice has melted to water, as you can see, the mass is still 33 grams. So in a physical change, the mass remains same. In a chemical change, the mass of the substance generally changes. Let's verify this with a simple experiment. For the experiment, I'm going to use this new candle and we are going to measure its mass before burning it and after burning the candle. I'm using this small candle because otherwise it's going to take a long time to burn. So first, let's measure the mass of the unburnt candle. The mass of the unburnt candle is 10 grams. Now I'm going to light the candle. Now let's measure its mass after burning. We are left with only 3 grams of the candle. So the mass of the candle has reduced by 7 grams. But doesn't this violate the law of conservation of mass? The law of conservation of mass states that matter can neither be created nor destroyed. So the mass should remain constant even for a chemical change. But in this case, we saw that the mass of the candle is decreasing. So how can you explain that? Well, the reason is we've been only looking at the mass of the candle. We haven't accounted for the gaseous products. Because when a candle burns, carbon dioxide and water vapor are produced. And they are gases. They go off into the atmosphere. And we've not accounted for their mass. So if this experiment is done in a different way, let's say we burn the candle in a closed container like this, then what do you think the reading is going to be? That's right. The mass of the container and the reactants will be the mass of the products and the container. So then the law of conservation of mass is going to be satisfied. The last difference is regarding energy. Now this is the confusing one because you find it expressed in different ways in different textbooks. In both physical and chemical changes, energy may be given out or it may be absorbed. But the amount of energy in physical changes is much smaller compared to chemical changes. For example, when you burn wood, you start the reaction with a small matchstick, so with a little amount of energy. But then we end up with a lot of energy in the form of heat and light. Now if you compare that to a physical change like melting of ice or boiling of water, energy is absorbed there, but it's much smaller compared to chemical changes. Let's pin the last two differences between physical and chemical changes on our concept board. So what do you think is the most important difference here? That's right. New substances are produced during a chemical change. But in a physical change, nothing new is formed. The irreversible point is not the most important one because a physical change can be irreversible. What are some examples? Cutting of a lemon or breaking of a glass. These are irreversible changes. But since nothing new is formed, they are classified as a physical change. For a chemical change, something new needs to be produced. Now that we are done with the concept of physical and chemical changes, are you ready for the top 3 questions on this topic coming up for you right now? Friends, I would like you to pause the video here and try solving these questions. Let's make this more interactive. So do post your answers and doubts in the comments below. And my commitment is to answer your doubts as soon as possible. I'm here to help and I look forward to reading your comments. So I'm going to move away now and let you solve these questions. So I hope the concept of physical changes and chemical changes is really clear to you now. I would encourage you to put on your thinking glasses and look for these changes in your everyday lives. I'm sure you're going to find lots of them.